there, folks. Thanks for inviting me into your homes once again. We're going to take a look at question 23 on the 2006 Gauss paper, the grade 7 Gauss to be exact. And it's a little late, but if you still want a copy of this contest, of course, click the link in the description. And try those questions out before watching me proceed through the rest of the paper. So, question 23. In the addition of two two-digit numbers, each blank space, including those in the answer, is to be filled with one of the digits 0, 1, 2, 3, 4, 5, 6, each used exactly once. So we've got 7 blanks, 7 digits to use. The units digit of the sum is... Okay. So this is sort of an interesting little puzzle. I remember doing questions not unlike this in a puzzle book I got when I was much younger. And it's just, can we work out the placement of these digits? Now, for this one, we don't have to work out the placement of every single digit, like you would in a lot of questions like this. What we really just need is to narrow down and get the units digit in the 3-digit sum. So once we get that, we can actually stop. We don't have to finish it. And it might be, although I doubt it, but it might be the case that there is no definitive answer that, this 2 digits, these ones have got to be there in this order, but there might be some way to only get, to only work out that units digit, and maybe not the units digits of the 2-digit numbers. Yeah. Alright, so we'll just proceed until we get to that point, and then maybe I'll go a little bit further, but what sort of observations can we make? Well, this 0 here is kind of intriguing because if these are 2-digit numbers and then with a 3-digit number, 0 can't be in any of these 3 spots. No. And while we're thinking about the tens digits of the 2 digits and the hundreds digit of the 3-digit number, while we know 0 can't be any of the leading digits, we also maybe ask ourselves, what's the leading digit of the 3-digit number? Okay, so we'll copy this guy down here just a moment. And it's a sum. Now, eventually we'll have to carry some stuff. What could we have? What could we have here? It can't be 0. We know that. 0 can't go, in any of these 3 spots. But what could we have? Could we have 6? Could we have 2? Well, think about it. What's the biggest 2-digit numbers we could even have? And now, obviously, we don't have any 9s to work with, so we could even say 6, 6, and 6, 6. But even if we just add the 9s, you're going to at most get something in the hundreds. So this blue digit, this leading digit for the 3-digit number, can't be 0. And there's no way to get him to be 2. Even if we had the biggest 2-digit numbers possible, you still wouldn't escape the hundreds. So this has got to be 1. So 1's off our list. And we know 0 can't go in a bunch of places. So 0's only got 4 places left to go. And maybe we'll keep track of what we've used. Okay. So now, we might ask ourselves, all right, where do we go from here? And our eye is always on the prize for this units digit here. But, well, we know we've got to get a 3-digit number when we add these 2-digit numbers, so you can't have something like 3 something and then 4 something. Because at best, these guys are going to be 9s. And so at best, this is going to be 8, carry the 1, and an 8. So we need, and that wouldn't get you the 1s there. So there's sort of a limit as to what the tens digits can be for our 2-digit numbers. Okay? Our tens digits have to, with a carried 1 at most, give us something in the teens, so 1 something. Okay, so we can't have 2, 3 and be the tens digit numbers, but we could have. Well, what pairs of tens digit numbers could we have? Well, we could have something like 6 and 5 You could definitely have 6 and 5 there. That would get you at least 11, maybe some more with a carried 1. What else could we have? We could have 6 and 4. That would get you 10, and that would be a great place to put the 0. We could have 5 and 4, because that would be a 9, but we definitely have to have a carried 1. So now we have to ask ourselves, well, can you get the carried 1 at that point? And 6 and 3, that would certainly do it, as long as we have a carried 1. So these two need a carried 1. Okay, we'll talk a bit about that in a moment. But that's really it. 6 and 2, that's 8. Even with a carried 1, that's at most a 90 for the sum. Okay, 5 and 3, same problem. Okay, now let's talk about these carried 1s. All right. So if I've got 5 and 4, what's left? Well, 1's already removed. And what would we have left? We'd have 0 to work with, 2 to work with, 3, and 6. No 2 of those will add up to give me something more than 10, so I won't be carrying a 1. So this one's out. Can't carry a 1. How about if we had 6 and 3? Well, we'd have 0 left, 2, 4, and 5. Again, at best, 4 plus 5 would go in the units digits, and you'd have something like 64 plus 35, and that's going to get you 9, no carried 1, and another 9. And that's not going to get us into the hundreds. So that's out. Both of those are gone. You can't get a carried 1. Okay? So that means one of these two options up here is required. And the only thing they have in common is they both use the 6. So the 6 can be one of the 10's digits. Let's put them here. But neither of these needed a carried 1. Okay? So as long as the 4 goes up here or the 5 goes up here, we're fine. So that means 6 is ruled out. We don't have 6 to play with anymore. Okay. So, what could we have? Well, if we had a 6 and a 5 here, let's talk about this one for a moment. 6 and a 5, it doesn't really matter what we've got over here. Again, we have too little to get a carried 1, and so you'll be left with 1, 1, and then some other number. In this case, 7. But we don't have a spare 1 to be working with. It rules out 6 and 5 pretty quickly. So, we got 4 up here, and we can't have a carried 1. So that'll put 0 down here. And then we ask ourselves, well, what numbers are left? So 0 is taken care of, 4 is taken care of. We've got 2, 3, and 5 left, and those have to be our units digits. So it's pretty quick to see, you'll get 2, 3, and 5. And of course, the 4 and the 6 can switch orders, or the 2 and the 3 can switch orders, but the point is the sum's going to have to be 105, and that means 5 is our units digit. Now, hopefully, we've got 5 as one of the possibilities. The units digit of the sum is D. 5. Okay? So this question was a lot of logic and thinking through. Okay? There wasn't a whole lot of, let's say, strict calculation. No algebra needed to be done. It was sort of an interesting brain puzzle, What could be my leading digit? Okay, how can I get that leading digit? What pairs work? Can I rule out some of the other pairs just through logic and knowing how basic addition works? And that's why I liked these sorts of puzzles when I was younger, and I still enjoy. I enjoyed this one, but I still enjoy these sorts of puzzles as I'm older. Okay? But, that's all it was. And I like to see this side of math on a math contest because it wasn't, can you do algebra? It wasn't, can you do geometry? It was, can you think logically and clearly? Can you rule things out? Can you realize the possibilities? Okay, so this is one of the things I really like about math, is that nice blend of logic. And you get that occasionally, far too rarely in my opinion, on math contests like this. So I'm glad to see one of these. And hopefully you enjoyed this question as well. That was question 23. In the next video, question 24, and then after that, 25, and we're done. So we're almost at the end. I'll see you guys for the next question in the next video.